All right, hello everyone. We're going to do our next section here, section 11.4, which is on measures of variation. As an overview, if we only look at measures of average, these two pictures of groups of dogs may trick us into thinking that their two groups are very similar when they're clearly not. If we look at the top picture, we see four dogs that are relatively kind of the same size. Maybe these two can be considered medium-sized dogs, and the other ones are more large-sized dogs. But either way, they're four fairly similar sized dogs. If we look at the bottom picture, we have a lot more dogs. We have 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 dogs, so we have twice the amount of dogs, but now we have them all lots of different shapes and sizes. We have small dogs, kind of medium-sized dogs here, some little larger dogs, and we have like one extra large dog here. So if their averages are fairly similar, we would think that their data or the groups of dogs are similar, but they clearly are not. And that is a difference in what we call variation. So the dogs in the first picture we see relatively similar in size. The second, they vary in size. Their mean weight is probably very similar since you have a lot more dogs in the second group and they have more of those outliers. So the really low values and the really high values, as opposed to kind of the values that are all very similar. So their mean weights are probably going to be very similar looking. And so this is why we study measures of variance. The descriptions of how data can vary within a set. This includes range, variance, and standard deviation. So those are the three things that we'll look at mostly today in this lecture. So range, variance, and standard deviation, we have the simplest of the three measures of variation is range. It's the difference between the highest and the lowest values in the set. We already learned about mid-range, which is a measure of average, where we take the lowest and highest values, add them, and divide by 2. The range is just the difference between the lowest and highest values. So it'll be the highest value minus the lowest value, and that'll be the range. The range is useful, but it's very limited. It only takes the highest and lowest values into consideration. So if there's an outlier, one number that is extremely large or extremely small, then the range ends up being skewed kind of in that direction. This is also why we define more reliable measures of variance, which we call, or variation, which we call variance, and standard deviation. So if we look at this picture here, this is kind of an explanation between range and standard deviation variance. So for range, we see there's a lot of people here and they're all definitely varying heights. The range is just the shortest height to the tallest height. So we see there's quite a bit of distance in this case. There's quite of a large margin of kind of the values that people can lie within. The standard deviation and variance will take the mean or the mathematical average here of all of the heights and then create kind of a range within those values saying this is where most people will end up being in. And if we look at this value, there's really only 3 of these 7 people in this group here that don't fall within this small kind of portion in here. So standard deviation variance kind of identifies more of a higher probability of data falling within a certain area within the mean. The range is just lowest to highest values. So while the range is very easy, it is not as accurate. So we'll start with an example here. We're going to remember how to find the mean. So we're going to find the mean of the following values: 70, 73, 58, 60, 30, 85, 40, 125, 42, 75, 60, and 55. So we're just going to remind ourselves what that is. Remember, the mean is the sum of the values divided by the number of the values. So we have sum of values divided by number of values. Let's go ahead and add these up. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. So we'll need to add all of the digits together and divide by 12 at the end. So we've got 70 plus 73 plus 58 plus 60 plus 30 plus 85 plus 40 plus 125 plus 42 plus 75 plus 60 plus 55. All those numbers added up divided by 12. That will end up giving us 773 over 12, which is about 64.4. So 64.4 is roughly going to be the mean of these values. So now we're going to find the range. So the range we said before was the highest value minus the lowest value. And in our data set here, the highest value was 125, the lowest being 30. So our range will be 125 minus 30, which gives us the value of 95. This is very skewed in this case because 125 is definitely a very high numbered outlier. The next highest number is 85. A lot of these numbers are kind of within the 70s. 30 is definitely low, but the next number is 40, so it's not that far off, while 125 is definitely extremely high. So we see this number very much skewed towards the higher numbered of values. So now we have range, variance, standard deviation. We'll go on to variance and standard deviation. So finding the variance and standard deviation is tricky, but there are steps that we can take to do it. So the procedure for finding variance and standard deviation is 6 steps. Step 1 is to find the mean. So you take the data points that you're given, find the mean. Step 2 is to subtract the mean from each data value in the data set. So you're going to subtract that value from every value in the data set. And then step 3, you'll square the differences. So all those differences that you found from step 2, you will square all of those numbers. Step 4, you will find the sum of the squares. So all of those values that you squared raised to the power of 2, you'll add all of those values together. Step 5 is to divide the sum by n minus 1, where n, of course, is the number of values, to get the variance. And that gives you the variance in that case. Standard deviation is what happens in step 6. Step 6 is the square root of the variance. That is standard deviation. Standard deviation is used a lot more often when actually finding certain things. Variance is more just the step to get to standard deviation. So a lot of the time we'll be asked to find variance and standard deviation, but standard deviation is a more useful measure in this case. So we have s squared, or s to the power of 2, is used to depict variance, because variance is just the square of standard deviation, or, the exponent of 2 of standard deviation. S, or that little symbol there, is the lowercase letter for sigma in Greek. So we have that is used for standard deviation in that case. So that is this very small sigma. Then standard deviation measures how far typical values are from the mean. So the size tells us how spread out our data is. So that's what standard deviation tells us. Standard deviation is telling us how far away the digits or the values that we are given, how far away are they from the mean, or how far away are they going to be from the mean. So you're really just analyzing, kind of finding this measure of average and then seeing how far away the values are from that average that you had there. If they're all very close together, it means that your values are all relatively close to the mean. And if it's very spread out, or if it's larger values, will tell you that those values are very spread out. So for example, we're going to find the variance and standard deviation for the weights of the dogs in the picture below. This was the picture that we had in the beginning there. We have our pictures of our dogs. We have the little Schnauzer is 30 pounds, the Husky is 85 pounds, the Basset Hound is 40 pounds. We have our Bernese Mountain Dog is 125 pounds. This is probably some sort of like pointer type of spaniel dog, is 42 pounds. Our Golden Retriever is 75 pounds. Our Dalmatian is 60 pounds. And our Bulldog is 55 pounds. So we'll go ahead and we'll find the variance and standard deviation for all the weights of the dogs in the picture below. So let's go ahead and do this one together. All right, so for example here, we're trying to find the variance and standard deviation. So we need to follow those steps that were on that previous slide. So we said our first step, step 1, was to find the mean. To find the mean, we need to add up all of our values and divide by the number of numbers. So we have all of our values there. Let's go ahead and add those. We'll have 30 plus 85 plus 40 plus 125 plus 42 plus 75 plus 60 plus 55. There are 8 dogs in this picture, so this will all be divided by 8. So when we add these numbers all together, we end up getting 512 over 8, which actually simplifies to 64 pounds exactly. So what we have here is that the mean is 64 pounds. So the average weight of these dogs should be 64 pounds. So for step 2, we want to subtract the mean from each value. We're going to subtract the mean from each value, and then step 3, we want to square those differences that we find. So focusing on step 2 first, let's actually kind of pull this down here because we'll probably write step 3 right next to it. We'll subtract the mean from each value. So starting with our first value, 30 minus 64, 85 minus 64, 40 minus 64, 125 minus 64, 42 minus 64, 75 minus 64, 60 minus 64, and 55 minus 64. All right, so we're going to find each one of these values. So this will end up giving us negative 34, 21, negative 24, 61, negative 22, 11, negative 4, and negative 9. All right, so we found, drop that one. We found each one of our differences. And I always say for step 3, we're going to square the differences. So our differences being the negative 34, 21, negative 24, all the way down there to negative 9, we're going to square each one of these values. So we'll take negative 34 squared. That will be 1,156. You just use a calculator for these. Then we have 21 squared, which will be 441. Negative 24 squared, we have 576. 61 squared, be 3,721. Negative 22 squared, be 484. 11 squared is 121. Negative 4 squared, 16. And negative 9 squared is 81. So for step 2, we subtracted the mean from each value. Step 3 squared all of those differences. Now we notice that the squares, they're all positive. That's because negative numbers squared become positive. So all of these numbers are positive. Now step 4 tells us to add all of these numbers together. So step 4 is to find the sum of squares. So you add 1,156 to 441 to 576 to 3,721 to 484 to 121 to 16 to 81. You will add all of those numbers up. So for this, you will add them all together to end up getting 6,596. So the sum of squares is 6,596. Step 5 is to take the sum of squares and divide by n minus 1. So divide the sum of squares by n minus 1. N minus 1 in our case, we know that n is 8. So that means that n minus 1 will be 8 minus 1, which is 7. So the n minus 1 value for us is going to be 7. This gives us the variance, which will equal 6,596 divided by 7. We're going to round this to 1 decimal place. This will be 942.3. So our variance in this case, it is telling us in pounds. So if we have 942.3, that's technically in pounds. Like we said before, standard deviation is the value that we use much more often to really describe situations. So our final step here, step 6, is to find that standard deviation. The square root of the variance is the standard deviation. So our value for our variance was 942.3. So the square root should be about 30.7 pounds. And that is our standard deviation. So there we have it. In this case, we say that most of our dog weights in this case should fall within about 30.7 pounds of the mean. When we say about 30.7 pounds, we're saying a little bit more and less. So about 30 pounds more and about 30 pounds less. All of our data should fall somewhere mostly within that smaller range that we have. So, all right, that tells us how to find variance and standard deviation. So let's go ahead and go back to our lecture. So when talking about variance and standard deviation of a sample, we call that sample variance or sample standard deviation. This is typically written with an S or an S squared for variance, S for standard deviation. We say the sample variance for a data set is an approximate average of the square of the distance between each value and the mean. If X represents individual values, then X bar, that's usually how we say that with a little line above the X, X bar, is the mean, and N is the number of values. So variance is found by finding the sum of the differences between the value and the mean squared, all divided by n minus 1. So all those steps that we just took, those 6 steps, this is all summed up by this one formula. The standard deviation would be the square root of this whole situation that we have here. And that provides us an approximate average of the distances between the data values and the mean. So everything that we just did is summed up into this formula, which you can use. You can choose to use this, or you can just choose to use the 6 steps. Either way, you're still doing the same thing. This is just a more compact way of actually writing it out. But you'll also see that very often where S squared is represented with the variance and S is represented as standard deviation. So we're going to do a last example here. I'm saying that I have 2 sections of Math 126 this semester. The 9:30 a.m. class has a mean score of 74% with a standard deviation of 9.2%. The 11 a.m. class also has a mean score of 74%, but their standard deviation is 3.6%. What can we conclude about the students' averages in these 2 sections? So we're going to use everything that we've kind of looked at so far in this section to try to do a little bit of analysis in a situation where the means are the same, but the standard deviations are different. Let's go ahead and go on over to our notes. All right, so we have the same question here. One thing that you may or may not have seen before is something called a bell curve or a normal distribution. So this is a bell curve. Our bell curve tells us that around the mean, we should be able to find a certain kind of intervals of values. So if we notice here, this has standard deviations. Those are 1 standard deviation. So within our mean, on either side of the mean, we should be within 1 standard deviation of the mean, either +1 or -1. So this portion right here is really representative of within ±1 standard deviation, which we can write as S, or we can write as the little sigma, which kind of looks like a 6. Which so any way that you choose to write it, S, or either way you can even just write SD. So within 1 ± standard deviation of the mean. And we see that this gets a lot larger when we start adding in more standard deviations. That range becomes larger and larger and larger. And so this creates this sort of bell curve. So the bell curve is telling us that most of your data will kind of fall within 1 standard deviation of the mean. And that the very high majority will definitely fall within 2 standard deviations. And just about all of your data should fall within 3 standard deviations. So that's kind of what this picture is telling us a little bit. So if we're given a very similar example for the 9:30 a.m. class and the 11 a.m. class, we have 9:30 a.m. We can kind of create a very similar kind of curve here. We're going to make it just a little bit different here. But so we've got, let's say the value of 74 is right about there, 74%. So our mean, which we can put right in here, our mean will tell us that this is like the most common value, but then our standard deviation will tell us kind of how close those values are. For the 9:30 a.m. class, we have a 9.2%. So our standard deviation might be a little bit maybe here. So this is our +1 standard deviation and -1 standard deviation. And so when we end up drawing this graph, it will probably look, something, well, maybe not quite like that, but something along this line. Since we have the about 9%, then that maybe is probably right around here for about, 65% on that test. So maybe looking a little bit more kind of like this. It's got kind of a wider bell on it, where our 11 a.m. class, they have a much smaller standard deviation. Their standard deviation is 3.6. Meaning that on this graph, where once again we have the mean, we could say 74 is right about there. Their standard deviation will be only 3% less, so probably around the 71% mark. Which would make our graph a little bit more. Let me mark up that mean real quick. That'll make our graph a little bit more, if I can draw correctly, a little bit more bell-like. You can imagine that maybe looks a little bit better. It'll probably have a little bit of a pointier, skinnier bell shape to it. There we go, that's better. So we'll have kind of this skinnier bell shape because the standard deviation kind of created a closer value to the mean. And so we end up with a skinnier, probably more dramatic bell shape as opposed to our 9:30 a.m. class where that standard deviation was lower, kind of widening out the bell shape. And so that can kind of be the difference if we kind of draw this out a little bit with a bell curve. And so at this point, we're just kind of trying to conclude things about the students' averages. So their averages could be due to a lot of different reasons. We can have conclusions here. We're seeing that while their averages were the same, that students in the morning class, their values were going to be farther away from that mean. So in the morning class, those values are going to be probably higher and also lower. So the 9:30 a.m. class probably has grades that are outliers, making them much higher and much lower. Our 11 a.m. class probably has grades that are all very close to the mean. So having a bigger value for your standard deviation essentially means that your values are going to be farther away from the mean, while a smaller standard deviation means that your values are going to be much closer to the mean. If we relate this to those pictures of the dogs that we saw in the beginning, our 11 a.m. class would be more like the 4 dogs that are all very similar in their weight. So those dogs, those standard deviations will be a lot smaller, even though we see that our means are still the same. The standard deviation is smaller because all of the dogs are much closer in weight, whereas same thing with our 8 dogs that had varying weights in our 9:30 a.m. class. Those values could be a lot more spread out. They could have outliers in that case. So we just see values are just more spread out in cases like those. So our 9:30 a.m. class, maybe we have a lot of really high achieving students and maybe lower achieving students as well. Maybe it's more of a mix. While our 11 a.m. class probably has a lot more kind of those average scoring students. Of course, you're going to have lower and higher, but a lot more of them kind of fall within the middle of that graph in that case, or within the values. So that's something that you can use standard deviation for. You can make conclusions about the way that your data is spread out within certain scenarios and kind of try to use it in that sense. So, all right, that wraps up our examples. Let's go back onto the lecture. All right, so that wraps up our section. In section 11.4, we learned how to find the range of a data set, find the variance and standard deviation of a data set, and interpret standard deviation. So, all right, that wraps up our section, and this will be the last section that we have here. So, see you again sometime.